Today, let's begin with Kubernetes. Right? What is this Kubernetes? Kubernetes is a container orchestrator tool. We have learned other container orchestrator tools, or else another tool in the same category. What is that?
Docker Swarm.
We have
Docker
learned,
Swarm.
yes, another container orchestrator tool called Docker Swarm, which has got limited features or like limitations of how well it can handle the applications. We'll be talking about the strongest container orchestration tool, Kubernetes. And before going to that part, let's talk a few more things about Kubernetes. Kubernetes is basically a product of Google. Right now, it is managed and maintained by CNCF, Cloud Native Computing Foundation. And this Kubernetes is considered as the most biggest open source infrastructure projects on the planet, right? And like the Kubernetes is basically written in Go language, right? Kubernetes can manage. See, container orchestration means in simple terms, it can manage containers at a large scale. Right. So Google has been using containers from so long, even before Docker came in. Right. They have been using containers for Gmail and all of this. And initially there was something like Borg, like in place of Kubernetes, and like so many, like it evolved. So many other technologies got evolved. Like from Borg we got Omega, and then from Omega we got Kubernetes. So it came up in almost like 2015, right? Yeah. And yeah, the name of Kubernetes, actually Kubernetes is a Greek word which means helmsman, right? And the logo also the same thing, the person who steers the ship. Here, steering the ship means maintaining, orchestrating the containers, right? And also in short, we call it as a Kubernetes, like in between you have 8 letters. So in short, we call it as Kubernetes. We have 8 letters between K and S. So that's how it is. And yeah, it came up in 2015. We have the first version one developed. Basically, it's in Go or Golang, whatever you call it. That's a short or a simple history of Kubernetes. Now coming to the actual features, like what it all does, like how why we should go for it. We have already Docker Swarm. Why should we need it? See, I can say Kubernetes is far advanced and extensively used in the real market. More than 50% of the projects uses Kubernetes. Means you can imagine how important or how widely it is used. Right? It has got all advanced features, and also the learning curve is also steep. Like you need to put lot of effort to learn the architecture to understand this. But once you learn it, yes, you have lot of uh, job scope or a job perspective, right? It has got huge demand and huge value in the market. So, okay, why it was gaining a lot of popularity or why it was so widely used? Main thing, it can help you maintaining high availability for your applications. Means high availability means it should be always means your application once you deploy it in Kubernetes, it should be highly available for end users without downtime. Yes, that's possible. Then scalability, right? Your application can be scalable at ease. Like you can scale down or scale up your application. Means it also loads faster and users can see high response rate from that. That's the main idea of scalability, right? You can scale them out or scale them in so that end users can see the application loading faster without any delay, and the response rate should be efficient. And also the disaster recovery, like something went wrong, okay, something went wrong, your infrastructure got collapsed or something, data is lost and all, right? So how to recover the lost data, right? So that containers can run from the latest recovered data. So all of that can be handled, taken care by Kubernetes. High availability scaling can be done with Swarm also, but like I said, limited, okay, drawbacks, limited efficiency or limited features. Okay, what are those limitations we have seen with Swarm? You will see all of them covered here. Okay. In Swarm, we just have seen high availability, scheduling the containers automatically, then scaling. Right here, we'll also see the other additional features like rolling updates, rollbacks, and many more. right? How to handle the stateful applications effectively. Like a lot many things will go through, right? So that's a few pointers about Kubernetes. And if you want me to compare these two in more detail, right? You for Swarm, you don't need a separate learning, right? It does. If you know Docker, it almost same like Docker. You don't need to learn it separately. But Kubernetes is a whole different or separate tool, and Swarm can manage only Docker containers because it's a product of Docker. It can manage only Docker containers. In the beginning, if you remember, like we discussed, there were so many other containerization tools, right? Do you remember that? Docker, Creo, Rocket, and so on. So Kubernetes not only orchestrates Docker containers, it can manage containers from any runtime, right? That is another difference. When you compare it with Swarm, of course, but Docker containers are famous, but still, Kubernetes can orchestrate containers from any runtime, right? Also, Swarm setup is very simple. You don't need to install Swarm. Have we installed Swarm? Do you remember? Have we installed Swarm separately? How did we use Swarm?
It
No,
is
we did not
came with the
write.
Yeah,
Docker.
we just did in it, right? If your Docker is installed, you can directly work in Swarm mode by doing Docker Swarm in it, right?
Yes.
So here, yes, setup is different. You have to set up Kubernetes separately. Also, one second, please, one second. So setup is different. Also, the setup varies from environment to environment. Meaning, let's suppose you want to set up on Kubernetes on on-prem. The steps would be different. Suppose you want to set up on AWS. Again, steps would be different, and there are multiple ways. Even on GCP, setup would be different. Again, it could be like a setup in multiple ways. Right? Only setup is different. Once it is installed and configured, how you work with it, the concepts, commands would be same. But yeah, again, setup would be a bit complex, and it should be like the decision depends on so many factors. So yeah, setup should be done separately. Like it is again a separate topic we need to learn, right? These are few things. And also when we talk about functionality wise, yeah, if you talk about rolling updates, yes, people say we can do rolling update here. Yes, possible, but can't promise zero downtime. Whereas zero downtime is possible here when you are doing rolling update. Rolling update means, okay, version 1 is deployed. Your containers are running version 1. You want to put a version 2 of those containers, right? You want to scale up, but there might be possibility of downtime seen, right? So how to overcome this? That is again possible in Kubernetes. So many such things you will understand the actual difference once we get into, okay, the architecture is totally different here. The architecture is very simple, right? Here architecture is going to be totally different architecture. Different components will be there, different moving components. Yeah. So yeah, once we get into each topic, you can actually realize the difference. So now let's get started with Kubernetes architecture. So once we understood the architecture, we'll go for its implementation. Right, good to go. Any questions in this part from anyone? And by the way, one more thing. In Swarm, yeah, we write Docker Swarm commands, right? Like Docker commands, one-line commands we do to manage our deployments or anything. Here in Kubernetes also you can run ad hoc commands like a single line commands. You can do that as well, like for certifications. I told you in the earlier classes, right? Like for certifications or for to do something quickly, you may do that one-line commands. But Kubernetes always prefers declarative approach. Means you define your deployments or you make your deployments configurations through manifest files which are written in YAML or JSON. Anything you can choose will be using YAML here. So that's a preferred approach and the best approach for Kubernetes, right? Anyway, we will get into each of these parts so that you will get clarity on. Any questions before I move on? Okay. Can you all see this diagram?
Yes.
Okay, so this is the Kubernetes architecture, right? Again, it's particularly Kubernetes is nothing but like you are talking about a cluster always, right? So in this Kubernetes cluster, you may have any number of nodes, right? This will be called as, I mean, this is called as a master node. And here you see they are called worker nodes, worker node 1, okay, worker node 2. Okay, we can have any number of nodes in our cluster. These worker nodes earlier or long back or in olden days, they may be called as minions, but now they were called as worker nodes or simply Kubernetes nodes. You will also refer these worker nodes as simply Kubernetes nodes. Kubernetes nodes means Kubernetes workers, and this is called the master node. Master node is also called as a control plane of the entire cluster. Do you see that? Control plane of the entire cluster. Control plane means which is a decision maker, right? Like which is a decision maker of all the things happening here. So first, let's talk about the components in worker node. If you see either master node or worker node, each of them are having different components, right? So let us talk about the components on worker node first, right? If you see here on the worker node, there were three components. Okay, first let's start with the components of master node itself. Just give me a second. This is the master node, worker node. Okay, you can have any number of worker nodes. Also, multi-master is possible. Multi-master should be there because either in Swarm or Kubernetes, if master goes down, it will spin up. Means entire cluster will go down. So multiple masters should be available. Okay, again, if you see, right, yeah, each node is having different components, right? Let's talk about the components here. I'm going with the worker node itself. So first component is called the pod. Do you see that? So what is a pod basically? See, till now we were discussing like you deploy the containers, right? Actual containers run on the worker nodes. But in Kubernetes, you will never see a container like this. You will never see a container running like this. Then, yes, your container will be always wrapped around a layer. That layer is called pod. Okay, why it should be wrapped around with a layer? Yes, that's like a home for the container. It's like an environment for the container to live. Every pod will be assigned with the IP address. It will have some network interface. The same network interface, the same pod IP will be shared by the container. Right? Every container will be wrapped around the layer called pod. Like you imagine a chocolate with a wrapper. Pod is like a wrapper, right? You will never deploy container directly. The smallest unit of deployment is pod. Means in Kubernetes cluster, you deploy the pods, you scale the pods, you delete the pods. That's how you deal with the pods. Basically, pod is the fundamental or the basic unit of deployment, right? So that you'll have this layer. And one container per pod is the best practice. You can have multiple containers also in the pod, but one container per pod is always the best practice, right? And yeah, so like I'm saying, yes, pod containers will be covered with a layer called pod. What is the importance? Does this pod layer has got any importance? Anyone can guess? Can think of any importance for this layer?
Firewall protection.
Okay.
Scalability.
Hmm. You scale the pods.
Yep.
So, okay.
It
See
would
this.
be, means I believe that it would be helpful to have access basically for any means, as you said, that it has a unique IP's address to this pods so that it can be accessible by any other orchestrator like Kubernetes. So that
Okay,
is the
see, let
flexibility what
me.
it provides.
Huh. Yeah. See, this pod is like a layer of abstraction. Layer of abstraction means Kubernetes can manage containers from any runtime. That's what we discussed, right? Kubernetes not only orchestrate Docker containers, it can orchestrate containers from any runtime. So they might be Docker containers, they might be CREO containers, LXC containers, Rocket containers, whatever it is. Any containers it can manage. So this pod works like a layer of abstraction. So let's suppose if some in your cluster, if you are using a different runtime, even the how Kubernetes works, how it is managing the containers remains same. So this works like layer of a abstraction. Got it, everyone? Understood. So that's why it was a we have this pod layer. Means basically how you deal with the pod still remains same irrespective of the container runtime used. So as a user, you have nothing to do with the container runtime. Right? You just deal with the pods. That's the layer of pod. That's the importance of this layer. I hope I'm clear. So that's the first component, pod. So basically your container, right? And then comes the second component, if you see, runtime, right? Which is Docker. Yes, container runtime, which is Docker, because see, see on this node I'm running containers means you should have Docker installed, right? Same is the case. Every worker node will have this container runtime installed because we were using Docker run, right? So that's all. That's the second thing. Third component is kubelet. Kubelet is the Kubernetes agent which runs on every node, right? Means the master node, like I told you, it's a control plane, it's a decision maker, right? It will give the instructions of how many pods should be running on worker 1, worker 2 and all. But how does this master interact with the nodes? Through this component called kubelet, right? So this kubelet also runs on every worker node so that the master, the main Kubernetes can connect with the worker nodes through this kubelet. Kubelet is the one which gives instructions, which connects with both the container and the node. Means, see, this is the node, right? This has got the containers. How does they interact? Through this kubelet. Kubelet starts the pod with the containers inside. Right, and kubelet is the one which assigns the resources to the pods. Even pods should have some memory, CPU requirements, right? Kubelet is the one which assigns the resources by taking instructions from the Kubernetes master. Clear with the third component, all of you? Okay, so that's a third component. Fourth component is kubeproxy. Kubeproxy, what is it? Again, it runs on every worker node. How to install them and all, we'll see. Okay. So kubeproxy is again it's another component. This is called as the network brains of the cluster. Means if you consider master as the control plane, right? And this kubeproxy is called as the network brains of the cluster. Means all the network communication, how how pods communicate, how pods on the same node communicate, how pods on different nodes communicate, all of them will be taken care by this kubeproxy. Got it, all of you? Also, let's say some application is running on the cluster. How end users can access this application, how those will create some services. So how services helps the pods to come have this communication, all of them will be taken care by this kubeproxy. So that's a fourth component. These four components runs on every worker node in the Kubernetes cluster. Clear with these components or any questions in these components?
Okay.
Okay.
Yeah,
So,
Prithvi.
mm,
Yeah,
okay.
like
Preeti,
every worker node have pod and every pod have container, right?
It's not mandatory. If you want to deploy container, that's how you deploy. See, we deployed some address book applications in the form of containers, right? So in Kubernetes, you deploy them as a pods. It's not mandatory you should deploy them on every node. But yeah, if you want to deploy, yes, every node on every node, these pods will run. See, in the Swarm, I explained like there is an option that you can also run the workers, run the containers on master, right? But in Kubernetes, we will never run them on master. Always master node will be tainted. Tainted means it will not take up any load, means you will not run, it will not run these pods. Clear?
Clear.
Only the pods will be running on the worker nodes. That's why I'm saying these are the components of worker nodes.
Kriti, can you please repeat kubelet?
Kubelet. Okay,
Concept of
Kubernetes is
kubelet.
the main component. Okay. How does master gives instructions to these worker nodes? Through this kubelet. Kubelet is the main Kubernetes agent running on every worker node. Master will give instructions to the kubelet. Kubelet is the one which starts the containers on the worker node. Kubelet is the one which assigns the resources to these containers by taking the instructions from master.
Yes, so basically it's like a client service which needs to be running and which is like an interface between master and the client.
Which service?
Client service.
Okay.
Yeah. So fine now,
Yes.
Preeti, it's clear. Yeah.
Yeah. Mm. All right. So now that we understood the components of these nodes, like we understood components of worker node, let's talk about the components of master. Okay, now we understood the components there, but the question is, how do you deploy them, isn't it? How do you deploy those pods? How do you interact with the cluster, first of all, isn't it? So that's where comes the master node. Means master node is, in master node, you have different components which has got the entry points like API server, scheduler, controller manager, HCD. Okay, let's go through each component one by one. The first main component is called the API server. This is called the brain of the cluster because this is the one actually, the actual decision maker or the one which is considered as the core component of the cluster, right? So if anyone have to interact with the cluster, yes, API server is like a gateway. It is like a gatekeeper for authentication and authorization. Also, I want to deploy some pods. How do you do that? Yes, Kubernetes has got UI, user interface, as well as the CLI. But like I said, I mentioned for every tool, CLI is always the preferred option so that you know actually what you are doing, what is happening. But UI is also there. Again, you cannot achieve complete functionality with UI, but just to refer the deployments and all, you can use it to a certain extent. So whatever it is, whether with UI or with the CLI, if you want to connect, API server will be the gate point. It's a single entry point to the cluster for security reasons. And okay, fine, I want to deploy some pod. Like we discussed some time back, you always prefer declarative approach. Means you write the manifest file. This manifest file can be written in YAML or JSON. We prefer YAML in the course and that's widely used as well. So we write the manifest file in YAML and you run the manifest file. When you run the manifest file, what happens? Like API server is the one which evaluates, which validates your input or which validates that particular manifest file. So once it validates it, once your API server validates it, what happens then? Means, okay, once API server agrees or else accepts it, it will send it to the scheduler. Scheduler is a second component. And what the scheduler does? The name is very simple, right? Scheduler. The name itself is saying everything. It has got the intelligence to decide on which node a pod should be deployed by calculating the CPU, memory, resources of that particular node, right? CPU, memory, network, all of that. It will check, it will calculate all these resources and it will decide on which pod, on which node this pod should go. So scheduler is the one which decides this. Once API server gives the instructions to the scheduler, scheduler will calculate all these resources and decides on which node a pod should be started at what time. And how it will do, it will interact with the kubelet. We have discussed the components of worker node, right? The scheduler will interact exactly with the kubelet. Okay, kubelet will get the inputs from the scheduler, and kubelet will start the container, means start the pods on the cluster. Also, whatever instructions it has given, it will assign those resources to the pods. Understood first two components, API server and the scheduler? Yes, or any questions, or should I repeat?
Yes, Prithvi, I must.
Okay, so that's two components. Then comes controller manager. What is this controller manager? See, as the name says, it has got so many controllers. Like you will see the different objects later. So just understand there will be so many Kubernetes objects. There will be controller for them like endpoint controller, application controller, pod controller, node controller, and so on. So basically what it does is, whenever a pod goes down, like let's say there are three pods, whenever a pod goes down, this controller should identify it and restart it. That's what is self-healing in Kubernetes, right? So it should start immediately. Controller manager is something like which detects some abnormalities and recover them, right? So, how it works at the backend is like it will have so many controllers, and what is the what is the purpose of them? These controllers at the backend will be running unending or continuous watch loops at the backend. It will keep on running some unending continuous watch loops at the backend. And what are those watch loops? Those watch loops will always verify the expected state, or sorry, it will always verify the actual state across the expected state. What is actual state and expected state? Expected state is the one which is defined in the manifest, correct? Let's say in manifest, I'll say I need 4 containers. That's a defined state or expected state or else desired state. Actual means what is actual in the cluster? Let's say on the cluster, there were 2 pods only. Means your actual state is 2, expected is 4, which is a mismatch. So this controller manager will have controllers regarding every object in Kubernetes, which will keep on running this continuous watch loops to check whether the actual state is as per the expected or desired state that is defined in the manifest or not. Suppose if it is out of the desired state, it's not as expected. This scheduler, this controller manager will make a request to the scheduler because controller manager cannot decide, right, where to start. So it will send a request to the scheduler. Scheduler will again calculate the resources available on those nodes and it will send the instructions to the kubelet. Kubelet will start the pod or delete the pod, whatever actions needed. So that kubelet will take the particular actions and it may start the pod or if required, it may take the pod down, whatever it is. That's a third component, controller manager. It's like a watchdog for the cluster. Right. So 1, 2, 3, these are the 3 components. Now that we understood, okay, scheduler is calculating the resources, deciding on which node a pod should be started at what time, accordingly it sends the instructions to the kubelet, and controller manager is getting the actual state and comparing it with the expected state, right? But how does scheduler and controller get all this information? Like how much resources available on worker node? How does scheduler know that? Or else how does controller manager know how many pods are running? What is the actual state? How does it know? Isn't it? So scheduler, controller manager, all of this will get this information from the next component called HCD. HCD is like a NoSQL database, right? It's like a storage. It's like a database, but NoSQL database where data will be stored in the form of key valued pairs. Which data? The cluster data, the configurations data, like how many pods are running, what are the resources available on each node, right? What is the actual state? What is the expected state? When were the changes made? All of that information, cluster configurations will be stored in the HCD, right? So means if API server is considered brain of the cluster, HCD is considered as the memory of the cluster, right? So it will have all this information. That's how scheduler, controller manager will fetch that information from HCD and make a decision. And HCD is also distributed, will be distributed across multiple master nodes if you have multiple master nodes, right? So that's how these four components work. These four components, because of these components, your master node is managing entire cluster. It's called control plane of the cluster. Got it, all of you? Any questions?
Pretty, how etcd will store the data from cluster? Like,
How?
what will
That's a
be the
component. That's a default component in the cluster, right? See, when you install this cluster, there are, like I said, there were multiple ways to do this cluster setup, right? You may install these components separately. You may connect them. That's how you will install API server. You will install scheduler. You will install controller manager. That's how you will install HCD as well. It's not only a Kubernetes component. It's like a NoSQL database. You can see HCD service outside also. It's used for storing some data. So all of them will be connected when you install, and that's how it stores the data. We have to do all that installation and connection.
Yeah, could you please make a arrow like etcd, what will be the next?
Mhm.
Uh,
Come again, please.
could you please make a arrow like which component will be the next after the etcd so it can connect with the worker node to store the like data? You just make a arrow na, in control manager to schedule
Make
and
a
schedule.
document, you mean?
No.
Mm.
So like
You're
my
asking me
point is
how to connect?
yes.
How to connect, like during installation, we will connect these components. We have to install these components and connect them during installation, during the cluster setup. See, like in Swarm, we will take 3 nodes, go to the master node, install each component separately. Then we have to establish a connection between them. Then they'll be communicating the way we discussed. That's all in the setup.
Okay.
Now that we understood the architecture, let us talk about the Kubernetes cluster setup. Right, like I said, yeah, cluster setup varies. Like you can choose how do you want to set up the cluster. There is a raw way of doing it, like you can choose then 3 servers, install these components one after the other, and set up the cluster. That is one way you can do, right? You can install all these components separately, but that will be very difficult because you have to manage everything from the scratch, installing those components and all. So what we can do is there were also setups like using kubeadm. There is a utility tool called kubeadm. kubeadm is a utility with which you can create the cluster. This is a kind of on-prem type of setup. Of course, here also you install them, but you when you start with kubeadm, all those components will be installed by default. Or else you have to install components separately. The raw method, which is too complex, we don't generally go for it. So kubeadm is a kind of way we can go with on-prem. Let's suppose you want to do it. Okay, let me write this way. You can install your cluster on on-premise servers like physical servers, or else any cloud like AWS, GCP, or Azure on any cloud as well. So if you talk about on-premise, like I said, you can do it in the raw method by installing each component separately and all, which would be too complex. Or else you can use kubeadm. With kubeadm, all these components get installed easily and you can go with it. Or when you go to AWS, again there were different options called COPS. Through COPS, you can install it. right? Or else you can take here servers and do kubeadm also. But the preferred approach on AWS would be, I would suggest EKS, Elastic Kubernetes Service, a managed service on AWS, a paid service. But if you use this service, setup would be very simple, and majority of the things like maintaining high availability for the master node, managing multiple nodes, all the control plane. See, setting up control plane is a complex part. Managing control planes high availability is a challenge in real time. All those will be handled by this managed service on AWS, right? That's one thing. Then if you come to GCP, yes, on GCP also there's a managed service called GKE. Means Google, yeah, one thing, this is paid and costly as well. So coming to GKE, GKE means Google Kubernetes Engine. Okay, this is also managed service of on GCP. Okay, here with a single click, you can create the cluster. Just with a single click, you can create a cluster. It's very easy to set up here, even in AWS rather than in AWS, because if you remember, Kubernetes is basically a product of Google. So this GKE comes like a pre-package with very easy steps. You can create a cluster. Also, it's absolutely free. Yeah. So you may be asking, yeah, because it was free, we can learn here. Yes, you can also do that, right? Like I said, only the setup differs. Other components, other commands, concepts remain same. So you can choose. Likewise, in Azure, you have something like AKS, right? Azure Kubernetes Service. With this, you can create a cluster easily. So you can choose now. Here, actually, first, I would suggest to go with this kubeadm kind of setup. kubeadm kind of setup will give you an exposure understanding how cluster can be made. But on-prem servers we don't have. So what we'll do, we'll create some VMs on AWS, some EC2 instances only. But we'll consider them like an on-premise because I'll not use any EKS or anything, but we'll use kubeadm and do the setup. So this is the first thing we'll do. Okay, so that you will know, everyone should know how cluster should be set up this method. Then when you learn EKS and GKE or AKS, you can easily understand. You don't, because majority of the times, there'll be separate team for cluster setup. There'll be separate Kubernetes team dedicated for cluster setup, whereas separate team for making the deployments, like Kubernetes admin team and Kubernetes development team. So they will do the setup. So one setup is done, like every cluster is same. But still, if you know kubeadm setup, yes, you can do the setup here or here, anywhere you can also do the setup easily. So first we'll go with kubeadm setup. We'll see the difficulties, drawbacks, limitations. Then we'll get started with EKS. This is the plan. So like I said here, in AWS, like we will take two separate VMs and we'll consider them like on-prem because we'll not use any other services. We'll install, kubeadm, and with kubeadm, we'll do this setup. So good to proceed. Any questions? Yeah, you may be having a question. Which one is widely used? Obviously, EKS is very widely used. I can say majority of the Kubernetes projects are on EKS. So EKS has got a great demand. If you know EKS again, yeah, that would be another benefit. But then why on-premise? Yes, because see, when you use EKS, like the cloud charges may be high at times when you have so many clusters, right? Because see, here in EKS, let's say I have two worker nodes. Those two worker nodes will be again EC2 instances, right? So you will be charged for these EC2 instances as well as for EKS service itself also you will be charged. So overall, when your clusters are huge, it may be very costly, but maintenance will be very easy. So companies can take a choice. Nowadays, startup companies, if they can't afford that budget, rather than they can maintain, they are moving to on-premise. Their own data centers, at least to manage the clusters. So it all depends on various factors, or else maybe the client who uses the application may need a zero downtime, or else They need a maintenance to be always like all the high availability should be taken care by rather than depending on manual maintenance. They may go for this EKS. So it all depends on various factors. Now let's begin with the kubeadm kind of setup, assuming those are on-prem servers. We'll take two EC2 instances and do the setup. Good to go. Shall we proceed? Any questions? Let me know. Meanwhile, I'll launch the instances. Let's take a two node cluster. Let's create a two node cluster. What I'll do, I'll go to AWS, create two instances. We'll make one master node and the other one as a worker node. Okay. So first let's go to the cluster. Sorry, let's go to AWS.
Are we installing a runtime engine on the master node?
Yes.
Kubeproxy or scheduler? Sorry, kubeproxy and kubelet.
Yes, yeah, we will install. With kubeadm, certain components it will take care of. We don't need to install each of them one by one.
In the architecture, it's not, the tool is not there in the master.
Which tool?
Kubelet, Docker, and
It was
proxy.
there, right?
No, in master.
In master, kubelet will be there because master also will have some default pods running. But actually here the kubelet purpose we discussed because that's where this gives instructions and kubelet will start them.
And also it will be kubeproxy and Docker also will be there in the master.
Yes, it will be there. Yes.
Okay.
Because it will also run the default pods. But when you talk about architecture, this is how we discuss. We don't discuss Docker on control plane and all.
Okay.
What is the difference between pod and container in Kubernetes?
Pod and container difference is pod will be a layer above your container, layer around your container. That's all. Means containers will be always wrapped with a pod in the Kubernetes.
Huh.
And what is its importance? It allows any container runtime. It provides a layer of abstraction. You just imagine pod is also a container, that's all. That's all, nothing else. But just imagine it is a layer. But when you are working, you just imagine it is a container, that's it.
Mm-hmm. Okay.
T2 micro, prepare. I'm allowing here all traffic. Everything else could be the same. I'm starting two instances with all traffic so that they can communicate. Let me name one as a master. These are EC2 instances. Just assume there are some on-prem servers. Because like I will not use any services, rather will install, configure them separately. So let's connect to this. This is going to be the master and worker. We need one more. So this is worker node. This is the master node. Okay, this is the master. So yeah, see, if you see, this is the host name, right? Their host names are different. Better we can set their host name so that we can easily identify them. First on the master node, I'm using host name CTL command. Let me switch to root. Right, so I'm setting the host name as master node. Here also switch to root. Worker node. So this is set as a master node and this one is set to worker node. Now they should resolve their host names, right? So on the master node and also on the worker node, we should set their host names in the HC host file. So leave those entries here. First, the IP address of the master, the private IP of the master. They have to identify, they have to connect with one another. So the IP address and the host name of the master. Similarly, the IP address and the host name of the worker. I'm having one master and one worker here. So we should also place these entries in the other node as well. So let's copy them. Save this. Here also on the worker node also do the same. HC host. What is the set enforced to 0? See, we have to disable security in Linux. It depends on the operating system to operating system. We were using CentOS based systems, right? Here for CentOS or Red Hat based systems, security in Linux will be enabled. For Kubernetes setup, we don't need the security SC Linux. So basically disabling it with set enforced to 0. That will disable security in Linux. And now that we made few changes, let's reboot the instances so that it will get updated with the host name and all. And let them restart. Okay, so this came up. Yeah, you can see the host name updated. Do you see that? Master node. Right here also it should be updated. Yeah. Okay. Kubernetes worker node. So all set. Right, this is the worker node, this is the master node. Done. Now let us download, let us install Kubernetes. So Kubernetes can be downloaded from like a repositories, but those repositories were not available by default in the yum repos. If you go to hc m.repos.d, okay, the default repositories were there, but Kubernetes repo is not there. So we can add it. Okay, I would like to create a file here with this content. I'm just adding this. See, I'm going to create a file called Kubernetes repo and adding the repositories from where it has to download. Yes, you have to do it on the master worker node as well. Right, the file should have been created on both the machines. See, Kubernetes repo. Now let us install the Docker, kubelet, kubeadm and all. See, here we'll be installing these components. Kubeadm. What is this kubeadm? Like I said, this is a utility, right, with which you can interact or with which you can manage your clusters, like create the Kubernetes cluster, delete them or connect to them. All of them can be taken care by kubeadm. So we need this utility. One more utility is required called kubectl. This is very, very important. Irrespective of whether you are doing a setup on-prem or on AWS or GCP or wherever, kubectl is called the command line utility. This is the utility we use on daily purpose to connect, check to do the deployments or to interact with the cluster. This is the utility we use. Whereas kubeadm is the utility to create and manage the clusters. This is the utility for interacting with your cluster. Right, on daily basis, this is the command we use. So this kubectl should be installed on every cluster, or else from wherever you want to interact, you have to install this kubectl. Right, this is the second component. The other thing is called kubelet. Right, like, yeah, we understood this. Kubelet is the most important component with which your API server will interact to start some pods. So kubelet should also be running on every node in the cluster. So first, these three should be installed. We can use yum to install them, and as we have added yum repositories, we can use yum to install all of this. And of course, Docker should be there, the container runtime. So see, this command will install Docker, kubelet, kubeadm, and kubectl. You can go with the same version. Okay, version compatibility issues may be there, so just go with stick with the same version. Similarly, the same thing here as well. And let the components install. Once those are installed, we should start kubelet and Docker. Okay, so the components were installed. Let's start Docker and kubelet. Systemctl start kubelet and Docker. Also, I want to enable this Docker and kubelet always. So systemctl enable Docker and kubelet. Right, so they were also enabled. Do the same for the worker node also. Right, so it was all set. Now we can create the cluster, and this is the one I want to make as a till now both the configurations are same, but from now onwards, whichever machine you want to act as a manager node, master node, this one, on that machine you have to do again Kubernetes init. Let me show you. This is the command you should run on the master node. See, kubeadm init, like you do swarm init, kubeadm is a utility to create and manage your clusters. So kubeadm init, API address, API advertise address, the private IP address of the manager node, whichever node you want to act as a manager, on that machine, you should run this command by placing its IP address. Right, that's the first thing. Next thing, okay, first let me replace this. Okay, that's the first thing. Next thing is pod network CIDR. Right, we will talk about CIDR blocks later, but just understand this is the IP address range that should be assigned to your pods. If you have custom networks, you can choose the IP address range you have. I'm just using the default range. Okay, so pods will be assigned the IP address within this range. That's all is the command actually. Then what were these? These two commands were important. These two flags are important. Like if you are using EC2 instances or any server, the prerequisite to create a cluster are every machine should have two CPUs and 2 gigs of memory. Right? Suppose if your instances doesn't match that criteria, you cannot create the Kubernetes cluster. So if you want to ignore that error and create, you can go with it. Right? So yeah, I'm just going with this because it needs two CPU and 2 gigs. Just if you go and try creating an instance. We were using T2.micro. Do you see that? See this one. T2.micro means 1 CPU and 1 gigs, but its minimum requirement is 2 CPU and 2 gigs. It will give you error. So add those flags so that you can still create the cluster, but your system, your cluster will be like they just work really slow. And also another thing is whenever we are learning Helm concept, okay, there's a concept called Helm. At that point, you definitely need more virtual CPUs. You can't install Helm with one vCPU and one gigs. You should just go with a T2 medium at least. If you want, you can go here itself, but yeah, you will be charged with some amount. But what you can do is you can still go with the same T2.micro. Later on, when we are learning Helm, you can do this. Or else you create a cluster on GCP once we learn those things. That is also fine. Right, but for now, yeah, it's T2.micro, so it's having only one CPU and 1 gigs of memory. So I'm ignoring those and start the cluster. So once cluster, like once it is ready, it will also give you a token, like in the case of Swarm. That token you should run on the worker node so that it will be added to the cluster. That's how you can create a cluster easily. See here, you can see API server, kubelet certificate, right? HCD and all the components getting ready. Yeah, it will take care of all those components. And here are the files about how those components were deployed. Right, finally your cluster is ready. It says, yeah, your Kubernetes control plane has initialized successfully. Right, yeah, if you can join any number of workers with this command. So copy this token, go to the worker node, run the token here. It should be added as a worker node. So, oh yeah, that's all fine. So we created a cluster with a root account, right? But you will not be having always root access to your cluster. You may have to connect as a regular user. So see, it was saying to start using your cluster, you need to run the following as a regular user because yeah, that's how it works. But what it is saying, make a directory in this path, make a directory -p means make a directory in this path called cube. See, whenever you create a cluster, sorry, home directory. I'm working as a root user, right? Just go to root home directory of the root. See, there'll be a hidden folders. There should be .cube. Okay. Let me go here. Yeah, it was here. I put it. Okay, so whenever you create a cluster, under HCD Kubernetes, there is something called admin.conf, okay, which will have all your cluster configuration. That should be copied into a directory called .kubeconfig, means it should be copied as .kubeconfig for anyone else to access. So what you should do if you want to access this as a EC2 user, first switch to that user. That's what I'm doing. Okay, I switch to root user, create a directory called .cube in the home directory. Now copy that admin conf file as config file in the cube directory, right? Also give the permissions. If you do this as any other user, that user have permissions to connect to the cluster. See, I'm as EC2 user. Now I want to check the nodes, kubectl get nodes. There were two nodes, right? Master node and worker node it was showing. Were there any pods? kubectl get PO. See, no pods it was saying. So finally you have got your cluster created with the two nodes. Right? That's all. Cluster creation is done. But here they were saying not ready because they were not yet connected. For them to connect, we have to install some network plugins. There were different network plugins like Calico, Flannel, and all. You already the manifest files for them were already there. You have to just do this command. What is this manifest file? We'll see later. Just run these commands that will install a Calico plugin on the master node. Now that we install them, again check the nodes. In few minutes, they should become ready. Meanwhile, if you see get pods, it was showing like no pods in default namespace. Do one thing. Namespaces are like namespace is separate concept. We will learn it as we go into the Kubernetes. But let me tell you, namespace is to group your resources. So if you want to check all the resources, all the pods, see, they were all default pods running. I told you, right? There'll be default pods running. Yeah, that's how your cluster works. See, API server is running as a pod, controller manager is running as a pod, proxy is running as a pod, scheduler. Do you see all of them? Yeah, some core DNS pods, everything was there. Calico network plugin was also there. So those are the default pods. They were all in kube system default namespace. Right? That's why you need Docker kubelet here also. So everything are ready means your nodes should be ready. Yes, status is ready now. Do you notice that earlier it was like not ready? Once all the containers, they were earlier container creating, but now as they were all ready, yes. Understood? Clear? Any questions? Anything you cannot run here, like kubectl get nodes on the worker node, see here, right? So all of these commands work from master. So this is the cluster creation. Clear, understood everyone? And also, yeah, we have created this kube config, right? So if you go to this hidden directory called kube, this is the one which is used for authentication. Okay, this will have cluster endpoint, cluster information, the data to connect to the cluster. This config file is very important to connect to the cluster. Anyone else want to connect to this cluster? Let's say, see, I'm running everything from master. But this is not a good practice. We should not be connecting to the cluster from master. What you can do is, if you have this kube config, you can also connect to this cluster from your local machine. That's how actually we'll do. We'll also do that later. Like in the coming up classes, when we create other clusters, we'll use with the kube config file. Means the point here is you don't need to step into the master and run all the commands here. You can just connect to it from our local machine and still access it. Anyway, let me show you here itself. Go to this kube directory config and just let me right. So you can create a .kube directory here. And we create a file here. This file should be placed in. Okay, this is how your kube config. Using this, you can connect to the cluster from this machine as well. Means particularly you should have this kube config file. Right, that will have a CA authority, the cluster authentication information. Right. So from here as well you can connect. But yeah, that's the whole point of kube config file. Even for the from Jenkins, if you want to connect, we'll provide this file. We'll also look into that a little later. So yeah, now the kube config file is ready. Like you are able to connect to the cluster and your cluster is ready with the 2 nodes. Let us see deploying some pods, right? So if you see actually like in the default namespace, we don't have any pods. Let's create some pod. And like we understood, pods or any objects in Kubernetes can be created through the declarative approach, through a manifest file, right? Let me create a file. You can give any name to the file. I'm giving as pod.yml. Then what to write in the file? How should to write a manifest file? You have always the official Kubernetes documentation for this. Kubernetes.io. Always prefer this. This kind of documentation help is used in real practice as well as you have the permission in interviews as well. Right? Because that's how we use, that's how we write the files. So you can feel free to use it. Pod, search for the pod. Even for certifications, you are allowed to browse this official documentation, certification exams or interviews. Of course, in interviews where they ask you to write the file, because no one should remember, can memorize this. They can just use this, modify accordingly. Okay, so right? So that is your manifest file. That's all. What is this API version? API version is the Kubernetes API. Okay, the standard version is V1. And then kind of deployment. Pod deployment means there were so many Kubernetes objects, Kubernetes REST objects. So pod is one such object. So kind will define, yes, it's a pod. And then metadata means you can give some name to your pod. And then come specifications. Inside the specific, because pod will have containers. Name of your container, the image name, and the port where your application is running. As simple as that. So what it will do? It will create a pod. Okay, pod name is Nginx. See, this information is about the pod. This metadata is for the pod. Inside the spec, whatever you have, this is going to be inside the pod, means the container data. So that's the name of the pod. This is the container name. What is the container name? Container name is also going to be Nginx. Within that, it would be running some image called Nginx with the label 1.14 something. And in the here, the application is running on port 80. So if you run this manifest file, it will create one pod with one container in it, and it might be running on any worker node. But how many worker nodes do we have? One worker node. So obviously it will run on worker node only. It doesn't mean like from where you are running the file. You might be running this file from your local computer by connecting to the cluster, or as of now it's on master. But where will be your pod created? You don't need to put them in kube config. Okay, just I have placed it. Okay, so here is the file actually. Now, how do you apply it? How do you run this? kubectl, for the first time when you are creating, you can use -f pod.yaml. F for file name, right? So just run the command. See, it says pod nginx created, kubectl get pods. See, it is still in the container creating state. In few minutes, it should be available. Yeah, see, it is running now. If you want to see more details about the pod, kubectl describe pod. PO is also fine, shortcut. Then See, it was showing name, default namespace, because I did not mention namespace. The default grouping is like a default namespace. And where it is running, you can clearly see worker node 1, the IP address of that worker. And every pod will be assigned with the IP I told you, right? And this is the IP. And if you remember, that is the CIDR range we have given to the pod IPs. Do you remember? With kubeadm in it, we have given some pod IP range. See, pod is assigned with the IP from that range only. And the Docker image, some port number, everything. This is the interesting and important. See here. Are you all seeing this? See, at the bottom, you can see how it was scheduled. 29 seconds back, it was scheduled by default scheduler. Successfully assigned it to worker node because we learned in the architecture, scheduler is the one which will schedule them. See, it has scheduled. Then kubelet came into picture, isn't it? Once scheduler schedules, gives the instructions to the kubelet, kubelet will start the container by pulling the Docker image. Then it pulled in 7 seconds, started a container, started Nginx application there. So these events will help you what happened 29 seconds back, 28 seconds back, 20 seconds back, your container is started. So when you describe, it will tell you like what happened and everything. So get pods will show you your pod running, right? That's your pod. And also you can see the IP address of the pod. Every pod will be assigned with IP. So those IPs, everything you can see when you describe, or else with output wide. This way also you can see. You see that? Nginx running in 2 minutes and the IP address. This is the IP address of the pod and this is running on worker node. Because nothing will be scheduled on master by default, master will be tainted in Kubernetes. If you want, you can remove it and schedule it, but that's not at all a good practice. Understood? Now this is the manifest file. Okay. So here one container, one pod is there. What if I want to start 10 Nginx pods? How to do that? How to do that scaling? Should I write this pod 10 times? Means should I repeat this manifest file 10 times or should I run the manifest file same 10 times? How it works? Isn't it? So how to scale my pods? That's the next question. Second question, okay, Nginx is running. Can I access the port of Nginx from the browser by hitting this worker node because it's running on worker? Let's see. Or else on master. Let me try on master itself on port 80. Or else from the worker. I opened all the ports if you remember. Right? It is not working. It will not work. So means how to expose my application to the external world. It could be Nginx or it could be address book, whatever. How to expose the applications, how to expose the pods, right? How to scale them, how to expose the pods. Yeah, how is all this possible? Not only that, we discussed like rolling updates, how to implement this rolling updates and all. Yeah. So to implement all these advanced features, never deploy the pod directly. What is meant by that? We learned, right? Don't deploy container directly. Containers never exist without the wrapper, so deploy the pod. But now what I'm saying, to implement all these advanced features, the best way to deploy pod in real practice is through a layer, means through another Kubernetes object called deployment object. These objects are the Kubernetes REST objects. Okay, so to deploy this pod, you can use another deployment object called deployment object. So if you deploy the pod through this deployment object, scaling, exposing them, rolling updates, all of them are efficiently possible. Here also you can do that through pod, but deployment is an advanced feature or advanced object which can handle them more effectively. Means imagine now deployment is like another layer over your pod. Don't deploy pod directly, rather deploy it via deployment through deployment object. So how is that? What is the advantages and all? We'll see. Like I said, it's another Kubernetes object, right? So what you will do? You will not use the kind anymore as pod. Kind will be deployment. And how to write manifest file for deployment? Again, the official documentation. If you just go here. And also see during this search, particularly in certification exams like CCAT, you should be seeing whether you are clicking the right link or not. Because in this search, sometimes you might be shown, see here, of course, this is also Kubernetes. Sometimes like by mistake, if you are going out of kubernetes.io, your exam will be like cancelled. So you have permissions only to view official documentation. So even you can practice that as well. You should not go to some blogs or something else as per the certification exam rules. So see deployment object. But how to understand this, we'll discuss and we'll explain. I'll explain this tomorrow and we shall do this tomorrow. This is the real way because see here you explain number of replicas, right? And many more. So that's the best approach. But yeah, this is the basic way. So in real practice, that's how we do. So, okay, fine. Let's say, okay, this is the basic way I don't want it. Just for learning we did. Now I want to remove this pod. Or else you can keep it and also deploy through deployment object. But let's say I want to delete it. Yes, you can do it. kubectl delete. Before that, one more thing. How to check the logs? kubectl logs. That's why kubectl I told you, right? Command line utility used to interact. This is the one we use on daily basis. Whether your cluster is created from on-prem or whatever. This is also kubectl logs, the image, I mean the pod name. Of course, there might be no logs here. So it was not showing anything. And then if you want to delete kubectl, delete pod name. See pod being deleted. Done. Now if you do kubectl get pods, no resources found in default namespace. We were doing everything in the default namespace now. Any questions?
Priti, do we have installation steps in Drive?
Yes, in the drive you have, in the website also you will have them. You have them in the drive.
Okay.
We'll share today's quiz a little later today.
Okay.
I'll post it in the channel. I mean in the group.
How do we browse when using this IP?
Sorry?
How do we browse the Nginx pod using this IP?
This one, get pods with output wide. Means it will give you more information, pod IP, on which node it was running, everything.
Yeah, so if we hit the IP, then it was not showing, right?
You can't hit this IP. This is pod internal network.
Okay.
We hit the IP address of the worker nodes, right? These nodes, like we did in Swarm and all with port forwarding, I mean port exposing. But it's still not working. Means we have to expose the pods. All right, then see, once done, make sure to stop them and you can start them once you are working. That will work. So that is all from my end. Any more questions from anyone else? Go through it, okay, and let me know if you have further questions. Okay, do some hands-on, set up your cluster and let me know tomorrow. Thank you all.